All right, we started this lesson yesterday, and so we need to continue talking about functions. What is a function? It's a special kind of relation. So first off, you got to have pairs. It's a relation. However, it's a relation where no ordered pair has the same x element, the first coordinate. In the common sense way of thinking it, no guy can date two girls or more, right? Any guy can only date one girl. Any guy can only be paired with one girl. And remember why this is the case. A function is something to where when you input any given number, you'll always get a definite output. And that will only work when each guy dates only one girl. That's the key to it all, that a given input has a definite output. And as we wrapped up yesterday with these examples that are not functions, what ends up happening is we don't have that. You know, example 2, if we input 5, okay, no problem, output is 7. If we input -1, no problem, output is 0. But if you input 2, now we got a problem. We don't know where to output. We can output to 4 or 6. How are we supposed to choose? And again, we're talking about aspects of math, a calculator, a computer, a computer program, software. It won't know what to output, and therefore then it is not a function. The thing locks up. That's the concept, that's the idea, and that's what we need to deal with in those first aspects. Jordan. Yeah, I didn't see your signal there. All right, so number 2. Functions can be visualized with a circle mapping. A circle mapping. It's a visualization, a picture of a function. That's all we're doing here. Making a picture of a function. A circle mapping. All right, it's real simple. I know they're ovals, but they call it a circle mapping. Honestly, they could be squares, rectangles, triangles. If you really want to put trapezoids, I guess you could. But normally it's just ovals. And really all you do is you list the members of the domain in the left one. So I'm just going to take my red and stick guy -1 in there. Stick guy 1, guy 2, guy 3, and guy 5. And then I'll take my green, and in the other oval, I'll stick in the girls. Girl -1, I don't know what happened to her negative. It's not green, but that's okay. Girl 4, girl 5, and do we list -1 again? No, of course not, because girl -1 is girl -1, and that's it. Now, it is really, really, really important that you do the mapping. Because here's what we want. If we didn't know what the set was, we want to be able to look at the circle mapping and know exactly who's dating whom. And to do that, we must actually do what's called the mapping. And the mapping is simply stating what guy goes with what girl. So if I take the 1, and I'm going to take my blue, and if I draw an arrow from, the -1, from the -1 to the -1 with an arrowhead at the right -1, I just mapped guy -1 to girl -1. Okay? Simplistic. And you have to do this for all the elements, all the guys. All right? Guy 1 has to be mapped to guy 4. Now, I don't know why this is the case, but I've been teaching this stuff, like I said, a long time. And for some reason, some students don't put the arrowhead on there. You need the arrowhead, right? You're trying to show the relationship of the guy to the girl, the input to the output. All right, so the 2 is mapped to 5. Now you got to take the 3 and map the 3 back up to -1, right? And you got to take the 5 and map the 5 up to -1. And that's a circle mapping. So if anybody didn't have the initial function listed and just looked at the circle mapping, they'd clearly be able to see guy -1 dating girl -1, guy 1 dating girl 4, guy 2 dating girl 5, guy 3 dating girl -1, and guy 5 dating girl -1. All right. -1 is popular. All right, so why don't you go ahead and do the second one? Go ahead and do the circle mapping. Pay attention to detail. Numbers of you, you're not good at paying attention to detail. Pay attention to detail. Be detail oriented. So let's see how detail oriented you were. How many put the word domain underneath the first one? All right, and the rest of you weren't all that detail oriented. And then I assume if you put the word domain, you did put the word range. All right, we do want to name our domain and range -1, 1, 2, 3. And what do we got here? We've got 7, 4, 5, -1. And these mappings are all just straight across, aren't they? Did you do arrowheads? I hope you did arrowheads. Do you think if you saw a circle mapping without the listing of the relation, you'd be able to tell whether it's a function or not? Would you? If you just had the circle mapping, would you be able to tell it's a function? Here's what I'm thinking, all right? You don't need to put this in your notes, just real quick, time's sake. Don't write this, just watch. All right, I want you to vote. Don't say anything out loud yet. I want you to think, is 1 a function, yes or no? Is 2 a function, yes or no? Everybody got it? All right, so we'll do 1 first. On 3, I want you to say yes or no to the question, is it a function? Both are already relations. Is it a function, yes or no? On 3, here we go. 1, 2, 3.
No.
I heard almost a uniform no. And that would be, all right, let's go ahead and do the second one. On 3, 1, 2, 3.
Yes.
Okay. And number 1 obviously has a problem because guy 2 is dating girl 4 and girl 8. It is not a function. And you are correct. And the second situation, even though everybody's dating girl 5, that's not a problem because no guy is dating more than one girl. And so that was a yes, and you have those correct. So from a circle mapping, it's easy to tell whether or not it's a function. You're just simply looking, again, is any guy dating more than one girl? Does any x value have more than one y value? All right, number 3. Function notation. I'm going to need you guys to focus in here, and I'm going to need you to ask questions if I'm not clear. This function notation, sometimes they'll say functional notation. It's like a language. Anybody in here speak another language besides English? Let me see your hands. Okay, so Spanish, Spanish, Spanish. All 3. Spanish, Spanish. What do you speak? Greek, Ileana? Camilla? Spanish. Okay. Anybody else? Raquel? Spanish? Anybody? Anything else? All right. You would think I would speak Italian. My dad came to this country, only spoke Italian, but he wanted to learn English, so he didn't speak Italian around the house. So I can't speak Italian. When I would go to my dad's parents' house, they only spoke Italian, so that was interesting. So whenever I was there, The conversation was, hello, Grandma, and she would say hi, and hi, Grandpa, and hi, and bye, Grandma, bye, Grandpa. That was about all of the conversation. They would try to talk to me, and then I would always say key, because key meant what in Italian, because it was always what. Whatever they said, it was like what? I have no idea. But language, and if you don't know languages, it's difficult. I do know a different language. Um, and I know this language fairly well, um, but not great. It takes a little bit of thought. So let's see. Stop you pop erop. Anybody know what I just said? No. I didn't say that. Let's see. What can I say? Hoppo wop, a rop e, yoppo you. That was how are you. That was how are you. Oh, shh, 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 shh. Let's try one more. What do I want to say? Gop o o dop, nop I gop hop top. Anybody know what I just said? No, see you. So the few of you that figured out the previous one, you just lucked into it. That was good night. It's op language. I was talking to you in op language. So not pig Latin, but no, op language is it's all spelling. So you take any consonants and you put op after it, and any vowel stays the vowel. Like I said, super in the beginning. Sop you pop erop is super. Sop e pop e rop. All right, but anyhow, here's the point. None of you really knew what was going on with op language because you hadn't learned the language. And function notation can be a little bit like that if you don't get a grasp of what it is. So it's basically it's a mathematical type language. So just be careful here. Focus in, and if you're not sure what's going on, ask questions. Ask questions. Ask questions. Ask questions. All right. So function notation is a way to show the value of the independent variable. And again, I'm going to use my red here, the x value. Functional notation is a way of showing the value of the independent variable. And you know what? Let me get my screen up here because I need to cover some of this stuff so I can focus you guys in. Okay, so here's our first couple of examples. So they gave us a function right here, right? And this is a function. And it's written in functional notation. So go ahead and take your pen and you need to write how to say this. I'm going to do this part right here in the front. The long way of saying it is a function of, so that little f all means a function of, and then what's in the parentheses comes next. I'm going to use my red, a function of x. And so this is really saying in words, a function of x equals the set of pairs -1, 4, 0, 5, 1, 5, 5, 7. Right? That's what's being said here. Instead of a function of x, a lot of times we shorten it because mathematicians love to shorten everything, and we just say f of x. F of x. So it means the exact same thing. It's just shorthand for a function of x. Okay. So we said here's a function f of x, and it's the set -1, 4, 0, 5, 1, 5, 5, 7. So I need somebody to raise your hand. Does anybody have any idea what the answer to this question is? Think about it. It's not hard. It's not hard. Let me give you a second. What find f of 0? Josh, what do you think? Anybody agree with Josh? 5? Okay, anybody agree with Josh? John, can you grab that door for me? Well, here's what Josh said. Remember, functional notation is a way to show the value of the independent variable. So this 0 is the x value, and Josh simply tried to figure out what girl is dating guy 0, and he was correct, girl 5. You're really finding the other one of the pair. F of 0 is what girl is 0 dating, and 0 is dating girl 5. All right, I don't know what you guys are looking at. Guy 0 is dating girl 5. What do you guys have? Something different? Really? All right, whatever. So this is a 3 on yours? You have a different version? The guy is 3 and the girl is 5? Okay. Really? All right, quiet. Quiet. All right, so you got a 3 there instead? Okay. Is that what you're saying? Just forget it. Stop talking, just forget it. Okay, so let's go by mine because that's the one that you can see on the screen. And we'll just go by what I have. So according to the screen, F of 0, guy 0 is dating girl 5. Guy 0 is dating girl 5. I don't know how those are different, but they are. So just make yours a 0 instead of a 3, I think is what you got to do. Yeah, that's what it is. Okay, so now that we all know that, look at the second one. F of 5 equals, get ready to give me an answer on 3. Here we go, 1, 2, 3, 7. And it's easy, right, if you know what's going on? I mean, if you know what it represents, it's easy. Guy 5 is dating girl 7. Peach cake. No sweat. We can do that. Well, now we have a little bit different scenario. Now instead of listing all the members of the set, we now have the set with what's called the rule. So we still have a function. This one would be g of x. G of x. And what it equals, because we don't list all the members, right? Do you see the members listed? They are not. But you know what is listed? A way to find who's dating whom. We've really done this concept already. And so this is called the rule. It's a matchmaker. eHarmony, maybe. Right? Christian mingle, yes. So, for example, in this room, if I needed to figure out the rule, I would probably go to the girls. So if I said Josh, I'd say girls, and you would say, there we go. See? It worked perfectly. All right, exactly. Worked great. All right. All right. That's what the rule is. It'll tell us who's dating who. So watch. When we say G of 1, what we're going to do is we're going to take the rule, and where the variable is, we're going to leave it blank, and we've done this before. And then I'm going to take my red, so I wrote the 2x minus 3, but where the x is, I put a parentheses. And by the way, you people that don't pay attention to detail, and I have people all the way through Algebra 2 that don't pay attention to detail, they won't put a parentheses there. I don't know why. I know why. Because they're stupid. All right? Has nothing to do with their intelligence, all right? They're just stupid. Because what happens is that parentheses keeps track of things. What's the 2 doing to the x? What's the relationship? Multiplying, right? And with a parentheses, doesn't it keep the fact that we're multiplying here It does, and it's important. A little thing like that really helps in a lot of different areas. And then we're just going to stick the 1 in there, right? To figure out who guy 1 is dating. And so we can finish this off in our head, right? 2 times 1 is 2. I'll do the next step. And so we all know 2 positives and 3 negatives leaves you 1 negative. And you know what? We just found out that guy 1 was dating girl negative 1. Guy 1 is dating girl negative 1. We had a rule to figure that out. We didn't see the list, but we had a rule that allowed us to figure it out. And so go ahead and do g of negative 3. Go ahead and find the answer to g of negative 3. Whoops. Whoopsie. Now you see how important that parentheses becomes, right? And hopefully you said negative 9, right? Now, we could also, and sometimes they'll want you to, and sometimes it won't matter. Sometimes they'll want you to list the solution in point form. So what if they did? So if we go back to number 1, if they say listed in point form, we would list the guy first and the girl second, right? 1, negative 1. Sometimes they're fine with just, hey, I just want the answer. Who's guy 1 dating? Girl negative 1. But sometimes they want you to list the final answer as a pair, showing the pair in point form. And so this one would be negative 3, negative 9, right? Again, certain problems want it one way, others another. Normally, for me, if it doesn't say, you're just going to give the answer negative 1 for 1 and negative 9 for 2. But knowing your homework, it'll occasionally say give the pair, and that's what you've got to do. Okay, let's go on. What else can happen? Find the range of the function f of x equals 5x minus 1 if the domain equals negative 3, 0, 2, and then write the function as a set of ordered pairs. All right, so we got to do all that. We got to do all that. All right, so not really all that hard. Anybody tell me how to get started on something like this? Andrew? Where should I list them? Okay, I agree. So we're going to put our domain underneath our x's, and might as well do all 3, right? Negative 3, 0, and 2. That's how we get started. Remember, the domain are always the x values. The range is always the y values. Oh, hey, by the way, let me show you one other thing. F of x in any functional notation is equal to and synonymous with a y. They are equal. So f of x or a y, same thing. One's functional notation, the other is just regular notation. They are synonymous. Well, let's go ahead and we'll stay in functional notation. So if I were going to figure out the girl here for negative 3, I'd do f of negative 3. Does that make sense? And really all we're doing is showing that first part. And we're going to finish it up the way we've done anything else. 5 in a parentheses and a negative 1, right? We'll stick our negative 3 in there. All right, just be careful finishing them out. You don't want to mess them up from here. So that's a negative 15 and a minus 1, and hopefully you say that's girl negative 16, right? Guy 3, and the guy negative 3 is dating girl negative 16. And we're going to do the second one the same way. Only this time f of 0, right? And again, we're just trying to figure out what girl goes with guy guy 0, and its girl -1. 0 times anything is 0, so that wipes out the front. F of 0 is always easy to find because it wipes out the part involving the variable. And then you'll finish off with your last one. This one only asked for 3 pairs. They could ask for 20 pairs. Guy 2. Again, you just, be orderly. Use your color. Make things look nice. See, part of your problem is that when you go to look at your notes, you don't even have what I have on the screen. I had to choose somebody out in Algebra 2 a couple days ago. You think about this class. The beginning of the year, did I supply notes for you to fill in the blanks, yes or no? Did you have to do a whole lot more writing? Was it a whole lot harder to keep up? Is it a whole lot easier to keep up now? So why would you be a fool and not write down what's on the board? My only conclusion is you're lazy. I don't know what else the other answer is. Besides, you're just lazy and you're not very wise. Because everything we put up there is so we can figure out what to do later on, right? And so we have notes to look back on and we can figure things out. So I don't know why you're not writing that stuff down. It takes 2 seconds, but you look back at yours and try to figure out what in the world you did. And of course, you're a straight A student, right? So obviously my lecture has no value there. It doesn't hold any meaning. All right, so hopefully you end up with 9. Are we done? Did we answer the question? Did we ATQ? No. Nope. So make sure we go back because it says, then write the function as a set of ordered pairs. So here's what we would do. F of x equals, somebody raise your hand, what would come next? Nick? Be careful. Just like this? Is that what you want? Everybody agreed? Anybody disagree? Don't forget the brace, all right? You got to list them in set notation. All right, and then we're going to go to 0, -1, and then we're going to go to 2, 9, and then we're going to close with a brace, right? And that would be listing them. We'll list the function as a set of ordered pairs. Right? That's the idea. That's the concept there. Not too tough. You'll see similar type homework problems in the homework. All right. Oh, I need my page 3. Let's get page 3 out here. What are we in? 9.3? Probably that one. Okay. All right, number 5. Determine if the graph of a relation is also a function. Now this last part here is for when you have a graph. Right? You don't have a list of points. You don't have it listed in set notation. You instead have a graph. And you want to figure out if the graph is a function or not. Now, please understand, graph lists a whole bunch of pairs. I don't have numbers. I should have probably put numbers on my Cartesian planes. But no matter what point you're talking about, for example, let's say a point right here. And I don't know, I'm just going to guesstimate. Let's suppose that's -2. And let's suppose that's a -3. So this would be the point -2, -3. Agreed? And honestly, every point on this line is a girl-guy pair. Every point along the line is a girl-guy pair. Every single one. Girl-guy pair, girl-guy pair, girl-guy pair. In this one, you got just 1, 2, 3, 4, 5 couples, right? There's one girl-guy pair, second girl-guy pair, third, fourth, fifth girl-guy pair. That one, there's only 5. This one, again, you got a whole bunch, really an infinite number of them. because you got this pair, that one, this pair, that pair, that pair, this pair, this pair, this pair, that one, that one, that one, that one, this one, this one, this one, this one, that one, that one, that one, that one, this one, forever, right? Going up, and all of the ones here, this pair, that pair, this pair, that pair, that one, this pair, this pair, this pair, this pair, this pair. You know, the pair might be like 0.1 to 0.5, you know, and these are all possibilities forever that way. And this last one again, this one, that one, this pair, this pair, this pair, this pair, that pair, etc., 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 etc. All kinds of pairs. There's tons of them. All right, so here's what we want to do. We want to determine if the graph of a relation is also a function. And believe it or not, it's really easy. All we need to do is the vertical line test. It's all we need to do. It's called the vertical line test. And it goes simply like this. If there exists a vertical line, so write in vertical again, if there exists a vertical line that intersects the graph in more than one point, then it is not a function, but only a relation. If there exists, in other words, if you can find one vertical line that'll hit the graph in more than one point, it is not a function. So look at the first example. I'm just going to show you a bunch of vertical lines. You can do this in your notes if you want. Does that hit more than one point of the red line? Does that hit more than one point of the red line? It only hit that one point of the red line, right? It's a vertical line. It only hit one point. Did that hit more than one point of the red line? Did that hit more than one point of the red line? Did that hit more than one point of the red line? Did that hit more than one point of the red line? Did that hit more than one point of the red line? No, it only hit one. It only hit that point of the red line. No matter what vertical line, does that hit more than one point of the red line? Does that hit more than one point of the red line? Does that hit more than one point of the red? No matter what vertical line I choose, I can't hit more than one point of the red line. You know what that means? It means every guy is only dating one girl. That's exactly what that means. And therefore, this is a function. It passed the vertical line test. It passed the vertical line test. All right, look at the second example. And I'll need you to ask some questions after I'm done with this one, but let me get done before you ask your questions. Does that hit in more than one point? No. So I guess this is a function, huh? It passed. Well, remember, it's if there exists any vertical line that hits more than one point. So, for example, what about that vertical line? That only hits one point, right? So far, it looks good. But what about this vertical line? We just failed. It hit more than one point, didn't it? This is not a function. Now, this is all in picture form, and that's where you got to be careful because you got to try to understand what's going on with the picture. So look, let's throw a few numbers in. Take your blue or whatever color you want. Let's call this 2 on the x-axis. Let's call this 1 on the y and 2 on the y, okay? Who is guy 2 dating? Who is guy 2 dating? He's dating girl 1, and he's also dating girl 2, isn't he? Shame, shame, shame. On guy 1, or guy 2. You shouldn't be doing that, guy 2. It's not a function. Right? So again, if you input 2, how do we know what to output? We don't know. I don't know whether to give the 1 out or the 2 out. It failed the vertical line test. Look, remember, whenever there's more than one point in a vertical line, that means that guy's dating more than one. That's the problem. So again, If there exists a line, if you can find a line that intersects at more than one point, it's not a function. All right, what do you think about the third one? Don't say anything out loud yet. Is the third going to be a function, yes or no? Does it pass the vertical line test, or does it fail the vertical line test? This is the graph of an absolute value. Does it pass? Did we do those in here, or was that Algebra 1? You guys know that an absolute value is a V? You don't know that, right? Okay. Algebra 1. Next, yeah. So does this pass or fail the vertical line test? Passes. Because look, I don't care what vertical line you pick and choose and try, you can't hit more than once. You're only hitting that red line one time. The red is the function or the relation. So that passes. So this is a function. And what about the last situation? Pass or fail? This thing fails all over the place. This guy's dating two girls. That 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 guy's dating two girls. Like a whole lot of guys. Almost every guy is dating two girls. The only guy not dating two girls is the guy right underneath that point right there. Is only dating one girl. And by the way, who's this guy out here dating? Nobody. Yeah. There is no pair there. All right. So, yeah, because it's all the function is all the pairs. So that thing failed all over the place. And by the way, you only need to fail once to fail. You only need to fail one time to fail. And so this is not a function. Got it? Kirsten. Well, again, is it hitting one or two red points? Only one red point, so therefore it's one. All right, I want to do something here with the homework because I don't want to give that many tonight. I thought I'd have a little bit more time in class, and I didn't. So I'm going to reduce this a little. So, by the way, notice 7 through 18, no originals. Those will really go fast. I think you're just saying whether it's a function or not. And you're using the vertical line test like we just did. So let's see. Yeah, that's all that is. So, all right. Let's get rid of all the review. Man, there's not that much review, is there? Bummer. There's no review. You know what? I thought I had some review and I don't. But you know what? These are going to go fairly quickly for you guys, a whole lot quicker than you would think. Let's see, 31 and 36 are the mappings, so there's only 2 of those, so that's good. And there's only a few of those. You know what? I got to leave it. It is bare bones already. It really is. Because it's a key concept. It's as few as I could give you to where I feel like you'd know the concept. So, believe me, a lot of those are a lot quicker than you think they are.